Okay, in this section, we're going to be using fundamental identities. There are 5 sets of fundamental identities that we'll be focusing on over the next 2 weeks. If you will look in on MathLab under document sharing, you will see a formula sheet. And on that formula sheet, that's basically all the formulas for chapter 5. But like I said, we're just going to be spending these first 2 weeks on 5.1 and 5.2. And so we'll be focusing on the first 5 sets of formulas. Now, the first 3 sets of formulas, I would typically have you memorize. Okay, and that's what we're looking at right now, these reciprocal identities. I'm still trying to figure out this recording stuff, and I actually made the whole video without any audio, so I'm trying to talk over it. We'll see how this works, but hopefully the next one will be better. Basically, with these reciprocal identities, they look new, but it's really something you've already heard before, because sine and cosecant are reciprocals, so sine would be 1 over cosecant. Cosecant would be 1 over sine. Same thing for cosine and secant. Okay, and then tangent and cotangent, and those are reciprocals. Okay. So just like we talked about on the unit circle, we just didn't really call them identities, but that's what those 6 are about. It's just knowing which goes with which. Okay. So hopefully that doesn't stress you out too much, because like I said, it's really not anything real new to learn. Now, the next set that I would want you to know and have memorized are the quotient identities. Now, for the quotient identities, we have 2 of those, so not as many, but these should not be anything very strenuous either. If you look at the first one, our first quotient identity says that tangent is equal to sine over cosine. And then cotangent is equal to cosine over sine. So while we really haven't seen them written like this before, that's still shouldn't be anything too stressful. And I do want to remind you that that circle with the line through it is theta. So we talked a little bit about this with the unit circle stuff, but we like to use Greek letters to represent angles sometimes. So you might see it as a U, but then you might see it with the circle with the line through it. Theta is probably the most popular Greek letter used. Okay, so don't let that part scare you. Now, we talked about how tangent on our unit circle, we know our formula for that. Tangent is y over x. Well, think about this for a second. What is y on our unit circle? Is it y sine? Okay, what about x? X is cosine. So we learned tangent is y over x, so it makes sense for it to be sine over cosine. We also know that tangent and cotangent are reciprocals, so cotangent's x over y. Well, isn't cosine x and sine y? Okay, so that's where that's coming from. Okay, so those 2 quotient identities would also be something that I would want you to know or to have memorized. The next set that I would want you to memorize would be the Pythagorean identities. And there are 3 of those. And with the Pythagorean identities, when you write those out, first of all, our first one is sine squared theta plus cosine squared theta equals 1. Now, doesn't that kind of look like the Pythagorean theorem? Okay, that's why these are called the Pythagorean identities. Okay. Now, this first one is actually derived from our formula for the unit circle. So do you remember when we were making our plate circle? I had you all turn it over and we wrote out the equation for that circle. Okay. our equation for sine squared theta plus cosine squared theta equals 1, or our equation for the circle was x squared plus y squared equals 1. Well, x is cosine, so x squared would be cosine squared. Y is sine on our circle, so y squared would be sine squared. Okay, so that identity comes from that equation. It's just x and y are in a different order. But when you're adding, it's the commutative property. It doesn't matter if you add x squared plus y squared or y squared plus x squared. It means the same thing. So that's where that one is coming from. Now, once you have that one down, and hopefully knowing that it's just the equation of a circle, hopefully that will help you remember that. But once you have that one down, we're going to come up with the other two identities from this first one. Sine squared theta plus cosine squared theta equals 1. So if you take that identity, and let's divide everything by the first term, sine squared theta. So if you divide both sides of the equation by sine squared theta, then the first term, sine squared theta over sine squared theta, okay, that's just going to reduce, those cancel out, and that reduces down to just 1. Okay, now cosine squared theta over sine squared theta. Okay, well, we just learned that cosine over sine, that was one of our reciprocal identities back here. Cosine over sine is cotangent. So if I'm squaring cosine and sine, then that's just going to equal cotangent squared theta. Okay, then looking at this last term, 1 over sine squared theta. Well, 1 over sine was one of our reciprocal identities. 1 over sine is cosecant. So if I just have 1 over sine squared, then I just write it as cosecant squared. So 1 plus cotangent squared theta equals cosecant squared theta. That's our second Pythagorean identity. Now for the third Pythagorean identity, same idea. We're going to start out with that first one again. Sine squared theta plus cosine squared theta equals 1. So I'm going to show you this in yellow just so you can kind of separate the three. Okay, if I take that for original identity that we started with, and this time instead of dividing by sine squared theta, I want to divide by the second term, cosine squared theta. So once I divide everything by cosine squared theta, then my first term, sine over cosine, that was one of our quotient identities again. Okay, once again it's squared, so sine squared theta over cosine squared theta is just going to be tangent squared theta. Okay. Second term, cosine squared theta over cosine squared theta, that just cancels out. So that's a 1, and I'm going to go write this in purple just so all of our three quotient identities will all be in purple. Okay. And then 1 over cosine, that's a reciprocal, that's equal to secant, so I just make it squared. Okay. So the three Pythagorean identities are the ones I'm starring here. They're the three written in purple. Okay. And hopefully, since you know where they're derived from, maybe that'll help you remember. Once again, if we were in class, then these 12 identities that we've just looked at, actually 11, isn't it? I would be giving you a quiz over do you have them memorized, okay? But that's not really feasible at this point, so just know them because it's going to make your life easier for the next couple of weeks. The sooner you know them, the easier the homework is going to be. And then also, if you were to see any questions on identities on the ACT, it would more than likely be one of these 11. Okay. So once again, you can find a copy of the formula sheet on MathLab under document sharing. But that is These are basically the identities we'll use. Now there are two more sets, the cofunction and the even-on identities, that are covered in this unit. They're pretty obvious though when you're using those, and you do not have to have them memorized. But if you'll notice, all the cofunction identities, and they are on that formula sheet that's on Math Lab, or they're in your book on page 372, they all have the parentheses around them, and it says like pi over 2 minus theta, or pi over 2 minus u. That's going to be a cofunction identity. All the even and odd identities, if you'll notice on those, see how in parentheses it's all a negative angle? Okay, so you'll see negative theta or negative u. Okay, I think on the formula sheet we may have typed a u just because that was easier to type than the theta, but same idea, that just means an angle. So for those 5 sets, it's really those first 3 that are used the most often that you definitely need to have memorized. And so, looking at these 3 Pythagorean identities again, there are actually alternate versions for each one that you need to be familiar with. So, for example, if we were to look at that first identity, sine squared theta plus cosine squared theta equals 1. Okay, we may see that identity, that same identity, but in a different form. And I'm recording this outside on my front porch because it's a beautiful day. So if you hear weird noises, that's what that's about. But anyway, taking that first identity, let's say that we want to rewrite it in terms of sine. Okay, that just means that if I'm solving that equation or that identity for sine squared theta, I would need to move the cosine squared theta over to the other side. So how would we do that? Okay, we would need to subtract, right? So sine squared theta equals 1 minus cosine squared theta. That's the same identity, just a different form of it. Okay. Now we could do the exact same thing by solving for cosine squared theta. When I solve for cosine squared theta, that would be 1 minus sine squared theta. Okay. So that's 3 different versions of the same identity. Okay. Now we can do look at the other 2 identities in the same way. So taking 1 plus cotangent squared theta equals cosecant squared theta. Let's say I want to solve for cotangent squared theta. I would need to subtract 1, so that would give me cosecant squared theta minus 1. And then if you wanted to solve for 1, that's going to give you cosecant squared theta minus cotangent squared theta. And then looking at our last identity, tangent squared theta plus 1 equals secant squared theta. I can rewrite that in terms of tangent squared theta by subtracting 1. Or I can write it in terms of 1, and when I do that, I would need to subtract tangent squared. So basically, when you are looking at these, how do you know what a Pythagorean identity is? You should see a trig function squared, and if you see a 1 added or subtracted from it, or another identity added or subtracting from it, it's probably a Pythagorean identity. Okay. Now, what we're going to do today is, like I said, we're going to be taking this really slow. We're only going to be doing the first 2 sections of this chapter over the next 2 weeks. So we're just going to look at one example today, and it tells us that the secant of u is equal to negative 3/2, and the tangent of u is greater than 0. We want to find the values of all 6 trig functions. Now, we solved problems like this in our first unit about the unit circle. We drew triangles to be able to figure out what the missing trig functions were. Okay. Yes, that is much easier than using the identities. However, the goal of this lesson is to get you comfortable with the identities. Okay. So we need to be using the identities even if there's an easier way. So here's what this is going to look like. Since it wants us to find all 6 trig functions, I need to find the sine of u, the cosine of u, the tangent of u, and then our reciprocal functions, cosecant of u, secant of u, and tangent of u, or cotangent of u, sorry. So I'm writing this out just like we did in the unit circle chapter, just to kind of give you a mental picture of which ones go together, okay? Now, first of all, we need to look at our given information. We know that the secant of u is -3/2. So that's what I'm going to fill in first. I'm going to write down -3/2 for my secant value. I also have a Sonic Route 44 Diet Cherry Limeade right now, and it is amazing. Okay, so since we know secant is -3/2 and we write that in, the first thing that I can think of is we automatically know the cosine value. Okay, because cosine and secant, how are they related? So you just use the reciprocal identity there. So on those, you really don't have a whole lot to show. You just flip the fraction like we've been doing. Okay. Now next, what I need to do, I've got 4 other things that I have to find. So I need to be able to relate one of those trig functions with one of the 2 that I know. So we want to think about all those identities we just went over, okay, and try to pick one out that will help us find one of our missing pieces. So the first thing that I'm thinking about is our Pythagorean identity. Sine squared u plus cosine squared u equals 1. Okay, I know cosine, but I don't know sine. Okay. So if I can take that cosine value of -2/3 and substitute it in there for cosine of u, then that should allow me to solve for sine. So we're going to do that substitution. And cosine squared u actually means cosine of u, that quantity squared. Okay, we just write the squared after the cosine instead of the u, so it doesn't look like a u squared. So I write down -2/3 and I square it. Well, when I square -2/3, what does that give me? All right, so I'm going to put my 4/9 in. And then to solve for sine, I would need to subtract 4/9. 1 minus 4/9 is 5/9. And then to get sine by itself, I need to square root both sides. Now remember, when you square root both sides, it's plus or minus. Okay, 5 doesn't have a square root, but 9 does, so it's plus or minus radical 5/3. Now, that gives me 2 answers. I just need one, so I need to figure out, am I going to use the positive radical 5/3, or am I going to use the negative radical 5/3? Well, we're going to need to go back to the original problem first. It tells us that secant is negative and tangent is positive. So when I look at my little all students take calculus chart that we talked about with the unit circle, I know that it's not going to be in quadrants 1 or 4 because tangent's positive. Sorry, I said that backwards. It's not going to be in 1 or 4 because secant is negative. Okay, so then that leaves us only one quadrant where tangent could be negative. Sorry, I said that wrong too. Only one quadrant where tangent could be positive. There's too many distractions outside, y'all. My husband just pulled in from work. Somebody's mowing their yard. Yeah. Anyway, so back to this. Tangent is going to be, or sine of u is going to be negative radical 5/3 because we figured out that we're talking about a 4th quadrant situation here. Now, sine and cosecant are reciprocal, so I'll just flip that, rationalize my denominator to get -3 radical 5/5. Okay, so now I have 4 of the 6. So I've got to figure out what to do for tangent and cotangent. So for tangent and cotangent, I have lots of options. Okay, so remember, when you are working through these, if you do get help with a friend or you're comparing work with someone else, as long as you have the same answer, you're good. and then you didn't use triangles, you did use identities. But there's going to be several different identities or paths that you can take to get to this answer. So for example, I could use another Pythagorean identity to get tangent, but let's use a quotient this time just so you can see how the quotient identities work. I know that tangent of u is equal to sine of u over cosine of u. Okay. Well, we found our sine value to be negative radical 5 over 3. So I'm going to say tangent of u is equal to negative radical 5 over 3, and then cosine was found to be negative 2/3. Okay. And so I can solve for tangent now. Now that is a messy fraction, but how do you divide fractions? You multiply by the reciprocal. Not quite the same with not having you all here to answer my questions, but I could tell you were thinking it. So that's going to give us radical 5 over 2. And notice it's positive because your negatives cancel out, and that works with what we had at the beginning when it said tangent was greater than 0. So I can take that radical 5 over 2, write that down for tangent, and since I know tangent is radical 5 over 2, that's going to leave cotangent to be 2 over radical 5. Once again, can't leave a radical on the bottom, so that rationalizes out to 2 radical 5 over 5. And now we have all 6. Okay, so just make sure you're showing your work with your identities so that we know that you are using the identities and not the triangles, because once again, the purpose of this lesson is to get those identities down, get them memorized, get you comfortable with them. Because we are going to spend time, the rest of the time over the next 2 weeks, doing some simplifying and verifying of identities, and it'll make life a lot easier the sooner you get those down. So here's your assignment. It's going to be out of the book. We're going to do 1 through 10 all, and then 11 through 23 odd. Basically, I'm trying to give you mostly odd so that you can check those answers in the back of the book. So make sure you are doing that when you show me, when you send me pictures of your work. I'm just giving you points on did you try them all. It's still your responsibility to make sure you have the correct answers. The 1 through 10 part is just like the identity, so I don't think that'll be as big of a deal. But make sure that you're in good shape on getting the correct answers. Okay, you all are so good about working together in class. And I hate it that you don't have that for this, because this would be a great time to be working together. But reach out to each other, FaceTime each other, help each other out. Of course, keep your social distancing going on, but help each other out and send me questions.